Hi everyone, hi hackers. This is Akshit. I'm from Team Huddle01, and today I'll be demoing a project built using OpenAI SDKs and Huddle01. So this is a tutorial for especially for the AI track and how you can use LLMs to integrate with the Huddle01 SDKs and build really cool DApps. So yeah, let's head over to it. So first of all, you'll need two things. One is the Huddle01 API key, and the other one is the OpenAI API key. So we'll be interacting with the GPT-4 API, and we'll be prompting the GPT-4 API and generating text to speech using it, and then converting that text to speech to a media stream and producing it to the Huddle01 SDKs. So it's going to be really cool, and let's go ahead. So for this tutorial, you'll have to get a good idea of how the Huddle01 SDKs work. I hope you've integrated it before. If not, you can simply head over to the Huddle01 docs, and here's where you can connect your wallet and generate the two credentials, which is the API key and the project ID. So once you're done with that, you can head over to whichever SDK you're planning on working with. So we have to React and JavaScript, and you can also do it on React Native. It uses the same React SDK itself. So if you head over to the walkthrough, you install two things. So we've installed both the server SDK as well as the React SDK part of this because we are assuming it's a Next.js app. So if it's a Next.js app, you have both the front end and back end in the same repo. But if not, if you have a separate Node.js server, then you should install the server SDK on that instead of the client. So that is one thing to note. Uh, so yeah, once you have the API key and project ID, you can simply go ahead and initialize your Hurdle client. So you can even check it out in the JavaScript side. Um, you have all this is in like proper sequence. So if you go to init, you initialize your client using the project ID, and once you do that, then you can join a particular room. So this is a room which where the peers can, produce their audio, video, or any other random arbitrary data packets too, like chat or maybe emojis. So you can do any type of communication using these SDKs. So in order to communicate that, you'll have to have a channel, which is particularly the room. So here you can simply join the room. Uh, you can do it on any client. So once you join the room, you'll be able to communicate via the SDKs. So if you haven't used the SDK, Huddle01 SDK before, I'd suggest that you go through the walkthrough and you'll be able to figure it out. It's pretty straightforward. And if you have any doubts, feel free to ping on Discord and we'll be available. So yeah, this tutorial is a little complex, so this is a prerequisite to have. So you can simply go to React if you're working with this, and this is like a 10-minute guide which will help you build a proper audio video communication app. So you can check this out. Then once this is done, like once you're familiar with how the React SDKs work and everything, you'll be able to build a app on your own. So today we'll be focusing more towards how you can run like this the client application on a Node.js server where you can process the audio video packets or like the text that you're receiving and send it to an LLM, process that data and send it back to the Huddle01 infra and simply to all the peers in the room. So it will be pretty interesting. So if you're able to do this, then you can interact, like you can create AI agents, like OpenAI agents to join the particular room and give tasks to them. Like create like a music bot, maybe tell them that play this particular song, like you tell to Siri, and they'll play a particular song. So we'll create a POC of how this can be done, and then you can innovate on this and build a app of your own. Right. So yeah, this is a short overview of how the Huddle01 SDK works. Now I'll go over the technical architecture of what we'll be building today and how you can interact with an LLM and produce responses from that LLM to a Huddle01 room. Okay. So yeah, let's move to explain draw, and I'll give a short technical overview of what we'll be doing. So this will be the Huddle01 infra, right? And to interact with this Huddle01 infra, you use the Huddle01 SDKs. So say you have a browser application, you install the Huddle01 React SDK here, and then you can call methods to the Huddle01 infra using Huddle client instance, which is somewhat like this. All right. You'll also need to specify two parameters over here. Uh, One will be the room ID, and the other one will be the total. All right. So let me go over how this will work. So this is like a browser web app where you're doing this, and you can simply call functions here. Right. So in order to get the room ID, you have to call an API to get it. To do that, if you head over to the Huddle01 docs and check out API references, here is the create room API. And if you head over to meeting SDK room API, you can simply call this endpoint with the API key that you generated before, and you get a room ID in return. And what I would suggest is that only run this API code on the server side and not on the client side, because if you risk like exposing your API key on the front end, and if the API key is exposed on the front end, then anybody can grab that API key and create access tokens and DDoS your room. So it's highly suggested to use this API on the backend side only. If you're using Next.js, then do it on the get server side props or recent server actions. That is the suggested method. Um, but only run this API on the server side. Then the other thing that the join room accepts is a token, and this token is basically a join room token. So you can generate this using the server SDK. If you head over to access token, even head to quick start, you can simply install the server SDK using this command, and you use the API key here and the room ID. So all this logic has to be run on the server side. If you do it on the client side, then your API key will be exposed, and then you risk compromising your application, right? So, and it won't really be like the server SDK won't really work on the client side either, because we have the course policy set up, so it won't work. So it is suggested to do this on the server side. All right. So once you have the room ID and the access token, you're good to join the Huddle01 room. And once you join the Huddle01 room, then you can simply produce your audio video streams or any arbitrary data to the Huddle01 infra. And other clients in particular could listen to that particular stream. So if I do Huddle01, like Huddle client or join room, then I can send over some data. So say I send over uh, a particular data. So if you head over to the JavaScript docs, then you can see that we have the send data functionality. And you can use the Huddle01 SDK to send over data to particular peers. So let me copy paste this command, and yeah, let me reformat it a bit. Okay. So if you send over this data, you can, if you specify to as star, then you're basically broadcasting this data to everybody in the Huddle01 room. So this is how you send data, and similarly, you can receive the data on the other end. So you can have multiple browser web apps interacting with the same room and um, communicating with each other. Or the other option is that you have a Node.js application which joins the room as a bot, say like a music bot if you want to do that. And that music bot can then listen to these streams and interact with it. So that's what we'll be looking into today. So once this send data has been done, you can simply listen to this data as well using this uh, receive data receive data event, which you can do on this side. Right? And once you receive this data, you can interact with this data however you want. So what we'll be doing is we'll be using the Huddle01 core SDK. We'll be installing it on this side. Let's color code it to something like orange. Okay. And this will be the web core. We'll install the web core SDK here. And once we install the web core SDK, we'll be able to listen to these events and everything. And once we listen to these events, then we can do whatever we want with the data. So say I said hello everyone. So this particular Node.js client will receive that hello everyone, and then we can use that hello everyone to, you know, give that to an LLM, convert it from text to speech, and then produce the response from the bot into the room. So what we'll do is we'll receive this data with this function, and once we have the data over here, say we have hello everyone, we will convert it to this, and we'll have the OpenAI SDK somewhat here. Let's get this color, and let's make this a bit bigger. Okay, so we have OpenAI SDKs. So we give this hello everyone to OpenAI, and it says it gives you a response in return. And it says like hello and chat GPT or something like that. Okay. And once this is done, then you can use this speech to text API or text to speech API actually to send over this response once again. And then this is also, yeah. And then you receive like a MP3 file in return, which is audio.mp3. And once you receive this audio.mp3, you have to convert this into a media stream, which is recognizable to the Huddle01 SDK. So you do a media stream, and we'll be doing this using a library called uh, A AO, AIO which is a Python library, but we'll be using a JavaScript wrapper for that. And once we have this media stream, then we can simply produce this media stream back to the infra. And once we produce it back to the infra, then any one of these peers can, listen to this media stream, and we'll be able to, listen to that particular bot talking. So that will be really cool. And this is how it works. If you have any doubts in the whole process, you can feel free to ping us on Discord. We'll be here to help you out. But yeah, this is how it works. I'll go through the process again. So you join the room on both ends. You send the data from browser web app, and once you do that, you receive it on the bot side. This Node.js app, which is our bot, and this bot then sends all the on the data to OpenAI SDKs, receives the response, then converts it into an MP3 using the SDKs again, and then converts it into a media stream and produces it back. So this is what we'll be doing. So we have two example apps over here. One is our browser example app, and the other one is our Node.js example app. We'll be going over both of them. So this is how the technical architecture is. All right. So moving on to the code. So if you want to check out the browser example app, this is the client Next.js example app, and you'll find this in the project resources on Global. So you can simply clone this repo and install the dependencies either using bun or pnpm, whatever works for you. Then the other one is this Node POC, which you can also clone. You'll find this link in the Notion, and the Notion is will be available on the global resources page for Huddle01. So yeah, you can clone both these apps, and once you clone these, then you'll be able to join a particular room and interact with it. So let's go over the browser tab app first and see how it works. So I've gone ahead and cloned both the example apps on the site. So this one is the Node.js example, and this one is the browser example. All right, so let me go ahead and install the dependencies. It's installed, and I can run bun dev, and I will get access to localhost 3000. So this is what the app looks like. It's pretty simple, created a very simple UI, and you can enter a display name if you want and join the room. Okay. Now that you've joined the room, you can enable the video. So say hi, so this is how it works. And I can join the same room using a different tab. I'll say, and you can see me, and I'll enable video here, then you can see it over here. And this chat also works, right? So you can see it like this. So now what we'll be integrating is that whenever I send a message through the chat, I want my Node.js bot to listen to that chat and interact with it and send a audio response back. Okay, and that's what we'll be doing using this Node.js app. So for the client Next.js example app, you can simply go ahead and check it out on the GitHub. And if you need any help on that, you can ping on our Discord server. It's pretty simple. Or even check out the Huddle01 docs. You can check it out. You can check out the walkthroughs. You can check out the React walkthrough. In this, we show how to build this app, and it's pretty simple. It's a 10-minute guide, and you'll be able to create a similar app like this on your own. Right? So head over to the Node.js app, which is the interesting part, and on how to integrate a Node.js app, like integrate the Huddle01 SDKs to a Node.js app. Okay. So you can skip all this for now, text to speech and response. I'll quickly show you how to get connected to the Huddle01 infra on the Node.js side first. So it's pretty simple. You install the Huddle01 SDK, the web core SDK on the Node.js app. So if you check out the package.json, you'll find that we've installed the web core over here. I'm using the alpha version over here because we've made some improvements to make it compatible with Node.js WebSockets. So feel free to go ahead and install the alpha version. You can do that using, you can do bun I at the rate Huddle01 web core with the @alpha tag. I'll show you why you need the alpha tag later. So you can simply do the @alpha tag and you'll be able to access this SDK. So once you're done with installing the web core alpha, then you can install the server SDK as well, as you'll need to generate tokens for the bot to join as well. So once you do that, you can simply initiate the client as we did before. We've given it the project ID, and we've given it some other options of active speaker and logging as true. So you can even switch this off if you'd like. Then this is the interesting part. In the alpha SDKs, we've given this functionality of adding a factory function, a factory handler over here. This is a custom worker factory which enables you to do certain things like modifying the media streams and sending custom media streams created on a Node.js server or on the server side. So I'll show you how this works. So make sure to install the Alpha SDK if you want to have access to this particular attribute. So what we do is we install this Media Soup client AIORTC package as well. So you can simply install this and get two things out of this. One is the AIORTC media stream, which mimics the media stream in the browser, and we use this to generate MP3 files. Like we use it to generate media streams from the MP3 file. We'll be going into that further. And to like create a worker to do this, you'll have to call the create worker function. So you can use the create worker function and you can define the log level. I've set it to debug, and you can create the worker over here. And once you have this worker, then you can create the handler factory and just pass it down to this. So this is like passing a custom handler factory to the Huddle client instance so that you can get access to more features and custom features such as producing AI or RTC media streams. So once this is done, you'll be good with the client side. And then what you can do is you'll have to have a room ID as well. So you can generate a room ID using the API. So I've already added the logic for generating the room ID inside the web example app. So if you run that, you'll already find this room ID over here. And you can copy this and paste it here. So for to make this work, you have to have the project ID and the API key pair match the room ID. So if you use the same API key pair to generate the room ID, only then you'll be able to connect to the same room. Otherwise, you will not be able to do it. Right? So you generate the room, you put the room ID here. Then we create the access token. So as I described in the while going over the walkthrough, you can simply call the new access token from the server SDK auth and create an access token for your bot. So what I've done here is that I've created a host privileged bot. So you can even dial down the privileges if you want, but for demo purposes, I've given it as host. And you can give it a display name or an avatar URL as well. And you'll have to mention the same API key you used to create the room ID. So once this is done and you have the access token, you'll be able to join the room from the Node.js side. So you simply have to call client.join room and pass it the room ID and the token. It's pretty similar to the web as well. We do this exact same thing here as well. And then the only difference in the Node.js one and this is that we pass a custom handler factory and we generate media streams from MP3 instead of accessing it directly via your media devices. So yeah, we'll be going over how to do that. So once you join the room, I've given it a sleep of 5 seconds. So it's a simple sleep function which resolves a promise and awaits for 5 seconds. So this works like a set timeout, but it says in plus. So I've made it like this. So after joining the room and after 5 seconds, all your event listeners will set. So once the bot has joined the room, after 5 seconds, it will be able to listen to room join. So it will give this, but this won't really trigger. So after 5 seconds, if anyone sends any data to the bot can listen to that data and process it. So before going ahead with this logic, I'll give you how the MP3 files are converted and how it works. So we have speech.mp3. I'll open this and I'll show you what this
I can
has.
assist you with a wide range of tasks and answer any questions you may have. Just let me know how I can help you.
So this is an MP3 file that I've already generated using OpenAI text-to-speech. And if you head over to the OpenAI docs and you see text-to-speech.
The sun rises in the east and sets in the west.
So this is the same voice that you heard before. So it was generated using this OpenAI text-to-speech model. And you can turn text into lifelike spoken audio very easily. So you can simply follow the Node.js guide on how to convert that. I'll also show you how I've done this in the code, but this is the gist of how it's done. You just simply pass it the input and you pass it the type of voice you want, and it will generate speech file for you, right? So we'll be coming over this as well once again. But just to get an idea, I've already created a speech MP3 file, which is started whenever the bot joins. They just speak this out, and they ask you whether like what all they can do. Okay. So we use the speech MP3, we resolve the path, and we create an audio stream using it, using the worker that we defined above. So this worker is then used to, get the user media from the particular MP3 file, and it creates it into a media stream. So this media stream then has the tracks for that particular audio, and that track is then, created using. Then we create a media stream out of it, and then we send this media stream back to enable audio, and this enable audio function is available on the local tier client. And what it does is it just enables the audio, like it produces the audio to all other clients on the Huddle01 infra in that particular room. So that's what it does. And I've also picked up this simple GIF kind of image, and I've converted this into a video stream and published this as well. So whenever the bot joins the room, it will first speak the text, and then it will also show the video of that it has joined. So to show this quickly, I'll run this Node.js server as well. So to do this, you can simply write dev, and it will run the server. And on the browser side,
I
we'll
can
be able to
assist
see.
you with a wide range of tasks and answer any questions you may have. Just let me know how I can help you.
Yeah, so what it did was it converted that speech.mp3 into a media stream and then sent it over to this room so we could hear it. And it also converted this video into a media stream and sent it over the Huddle01 SDKs and rendered it out here. So this is how it's working. Then moving on to the logic where you can chat with it, that is pretty cool. So I hope you understood this part. This is the main thing that we're doing, and this is how it works. So before going on to receiving data from the chat and interacting with that, I'll quickly show you how like I'm prompting the OpenAI API and getting the data and converting that data to text to speech. So we have two things over here. So I have created this function get response from GPT, and it accepts an array of messages. So how the GPT-4 completions work is you have to pass an array of the whole conversation to the OpenAI SDK. So if you pass the whole array of messages to the completion to the GPT-4, then what it does is it analyzes the whole conversation, and based on the answer that it has provided before, and the based on the question that you've asked it before, it gives you a particular answer to that. So to see what it looks like, you can check out this interface. So I've created this content, so this interface which has a content field, which is just a simple string of like what the message is. So if I say hi, good morning, the content will go inside this. Then there is this role field, which the OpenAI SDK itself accepts, which is basically the system or the user, whether that message is from the user or whether it is a response from ChatGPT. So that is what this role defines. So what we're doing is that whenever we're sending a chat and we're receiving a response from GPT, we're storing it inside an array to keep a track of the conversation, and so that we can send it back to GPT APIs and get a relevant response. So yeah. So whenever you give it a messages array and you give the whole context of the conversation to GPT, it processes the whole conversation before, and it gives you an answer in return. So this result is basically a string which it gives, and we just return that particular result. That's all it does. It's very simple, just 20 lines of code and we're done. Okay. So this is how the text generation works. So whatever your conversation is based on that, it will give you a particular response. So once we receive that particular response, then we want to convert that into an audio. So to do that, what we do is, not this, we have a text to speech function, sorry, and what it wants a text file as an input, and then it converts that text file into an MP3. So we pass the input as string. So the input is basically the response that you received from ChatGPT, which I showed you before. And that response, we send it to text to speech, and it accepts it as a string, and then converts that text into an MP3 buffer. All right, and we use convert that buffer into an MP3 file and write it to the system using the file system. All right, so the logic that I've written here you can ignore for now. So this logic you can ignore and just see this part. We simply put the input inside here and we receive an MP3 file as a buffer, and then we convert that buffer into a file. So we write that file into our system itself. So I'll show you how this works once I send the data. So let me say I what is 2 plus 2. So now it has generated the speech file as an MP3. So we've received this message as 2 plus 2 equals 4. Right? And once this message has been received, then what you can do is you can simply convert this message to an audio stream. So I'll show you how that's done. So once we have this speech.mp3 over here, what we do is we grab this mp3 file and then we convert it into a media stream and then send it over. Let me show you where that's done. Okay, I hope you understood the part where the conversion is taking place. Now we can move on to the part where we send data. Okay, so let me just uh, restart this out. And I'll just create a new room. Yeah, alright. Okay, so before showing the demo, I will quickly show you how the chat functionality is working. So whenever I'll join this room, and whenever I say like hi over here, what it does is it sends like a send data message that I showed you in Xcali. So it gives you this local peer.send data and sends like a hello everyone to the server, and then we can listen it on the other side. So once I send it using this particular function, okay, then I receive it on this end. So I do receive data, and then this is the data that I've received. And I just check whether if it's the bot who sent the message or if whether it's a person who has sent the message. So if it is not a bot, then I just push the messages in to the array. Otherwise, I say processing reply from the bot. And um, once this is done, like what I do is I put the messages array which the user sent and get a response from GPT. If there's no payload or error, then it will show no payload, but this likely won't happen unless you have a networking problem. But then you have a payload, and you push the messages to the message to the messages array with the response you get from GPT, and uh, then you create it text to speech. So this count just returns the MP3 number of the file which has been returned and keeps a track of them. And once you have that, then you just simply write it and grab the file from the path and convert it into an audio stream. So you convert the text to speech and you write it to file in this function. And once the file has been written, you read that file and convert it to an audio stream. And then that audio stream is sent, like we disable the audio and then enable the audio and send the audio inside here. So once this is done, you can even use the replace audio stream function, but just to show you how this works, I've done this. So you can even use the replace audio stream to replace the current audio stream with the new one, and it will spit out the audio. So this is how it works. Let's quickly test this out. So one quick thing to notice, whatever files that are generated, you'll have to delete at the end of when you close the server. So keep that in mind. I'll do one dev, and I should receive the bot speaking anytime now. Okay, I think I've used the wrong room ID. Let me update the room ID real quick. So I've updated the room ID, and I can join this room. Okay, now the bot has joined.
You with a wide range of tasks
So now
and
you can
answer
hear the
any
bot.
questions you may have. Just let me know how I can help you.
Hi. Can you do some maths for me?
I'd be happy to help with any math problems you have. What do you need assistance with?
And say what is sine x by cos x in terms of tan.
Functions sine x and cosine cos x can be related to the tangent function tan x as follows. By definition, the tangent of an angle x is given by tan x equals frac cos therefore frac sin x is equal to tan x. So in terms of tangent, we have frac x equals tan x. If you have any more questions or need further assistance, feel free to ask.
See how perfectly this works, and you can even see the response logged over here. So this is the messages array that we've been maintaining, and based on the previous conversation that we have, like the whole flow of the conversation, it gives me a particular answer and speaks it out. So yeah, this was the tutorial, and I hope this helps. Any doubts or any questions that you have can be forwarded us to on Discord, or you can ping me as well personally, no problem. I'll help you out. And you can check these two repos out on the Notion doc. It will be mentioned there. And you can also find it on the Huddle01 GitHub as well. It will be definitely be mentioned on the global prices section. And yeah, I'm curious to see what you all builders build using LLMs. And yeah, kudos on building.